Hi, my name is Dhruv, and in this video, I'll be giving you a walkthrough of my Fragments microservice project. This system is designed to manage various types of fragments such as text, images, and JSON, leveraging several AWS features for scalability, security, and performance. Let's start by taking a look at our Fragments API server that I have deployed on EWS, ECS, the Amazon Elastic Container Service. Here you can see the health check route, JSON response by accessing the load balancer URL in the browser. ECS was used to manage and scale Docker containers, ensuring that our backend service are reliable and can handle varying loads efficiently. This health check route confirms that our API server is up and running. Now I'll demonstrate the Fragments UI web app running on my local host. Here we go. This app is connected to our Docker container running on EWS and integrates with the Amazon Cognito user pool for authentication. First, let's log in using Cognito hosted UI. After successful authentication, you can see all the existing fragments. I don't have any yet, but we'll create some soon. Next, I'll create a few fragments. Let's start with JSON. Here we have a JSON fragment, and now we'll post it. All right. I'll also create a markdown fragment. All right. An HTML fragment as well, just for testing, and an image fragment. All right, now we have four fragments over here, and we can start testing these out. You can see each fragment is being added to a list as soon as they're created, confirming successful interaction with our API. We can click on the fragment and see the metadata. All right, one of the key features of this application is the ability to convert fragments between supported types. Let's convert the markdown fragment, for example, into an HTML. Here we can see now it's now been converted into an HTML. We can convert it back to markdown. It can also be converted to text, which just looks similar. So convert it back to markdown. This interaction demonstrates that the code has a seamless integration between our front end and the ECS hosted backend. All right. Similarly, I can convert the image into different formats as well. So the image I've uploaded is a GIF, can be converted into PNG, JPG, WebP, or AVIF. Let's convert it into PNG. It's now been converted into PNG. To check, we can just open it on a different tab, and over here it says it's a PNG image now. You can convert it back to GIF, convert it, and let's just convert it to AVIF. Now it's been converted into an AVIF. We can see it from over here that it's an AVIF fragment now. All right. Th- this demonstrates the versatility of our API in handling different types of media, ensuring that the users can work their data in format they need. All right, next let's modify an existing fragment. Let's say the HTML fragment. No, all right. Let's first delete a fragment. We'll delete this one, and it's now gone. We can also update fragments. For example, over here, you can update it. Okay. And once we update a fragment, the updated date and time changes. to the current time and shows the updated fragment over here. We've added console log messages to ensure everything works fine and to see if we to catch any errors if they're caused. Let's convert the JSON into a YAML file and YAML code, and let's see if the console log works. Convert it here. It says converting fragment to YAML for ID this, and the code has been converted to YAML now. That's how our application basically works. Convert it back to JSON. All right. Now let's take a look at the AWS CloudWatch. If it is used to log our API server's activities, I'll make a request to the API and then we'll check the corresponding logs in the CloudWatch. All right. Let's just make another request over here, a text fragment, and submit it. We can see it's been submitted. We'll now go to CloudWatch to check if our fragment is issuing logs. Go to the ECS, the R fragment service, logs, and we'll watch our logs in the CloudWatch system. Here we'll look for the post log that should have been issued because we just posted a fragment. All right, now let's just look the recent logs. All right, should be somewhere here. Hmm, Set, yeah, here it is. This is the post request that we just made on our server. The post request for the fragment we just created, followed by a get request to display the fragment as well. CloudWatch was chosen for monitoring and logging because it allows us to track application performance and troubleshoot issues in real time, ensuring that the reliability of our services. All right, other AWS services we used were Cognito, which is over here. Cognito is responsible for user authentication and management within our application. It enables our sign up and sign in process while handling user credentials and session management automatically. Next up, we have ECR, which is over here. This is where our Docker images are stored. All right. By using ECR, we ensure that our Docker images are easily accessible and can be deployed across various environments without compatibility issues. Next up, we have the ECS, through which we just use the CloudWatch. This is our ECS, the fragments cluster we created. ECS provides a highly scalable and reliable way to manage containers, ensuring that our application can be handled varying loads by automatically scaling up or down based on the demand. All right, we also have S3 storage. It is used for storing fragments data, especially images. S3 is highly durable and scalable during a storage solution, making it ideal for storing large amounts of data securely. Here we have the data we just created. All the fragments we created and deleted are stored over here. The fragments we deleted are also removed from this place. We'll just open one of the fragments. This is how it looks like. We can download the fragment, which looks something like this. Let's open it. All right, this was the text fragment that we created. You can see it over here. Also, we're using Amazon DynamoDB. We created a table in here named fragments with all our data in it. Yeah, here are all the fragments we created. This is the GIF image that we created. This just contains the metadata and not the actual content. It is highly performant, providing single-digit millisecond response times at any scale. All right. Additionally, I also implemented HTTPS secure setup with a custom domain and SSL certificate, which is over here. This is the custom domain that we used. This setup ensures secure communication between clients and the server, which is essential for protecting user data and building trust in production environments. It also shows the flexibility of AWS services in handling real-world security requirements. All right. Um, just Also we implemented download features. We can always download this GIF image as a PNG and store it on a local device. Here we have downloaded it as a PNG. You can see the extension. We'll delete it for now. All right, in conclusion, this project successfully implements a microservice architecture using AWS to manage fragments with robust functionality for handling different fragment types, conversions, and lifecycle management. The integration with the AWS services provides scalability, security, and performance enhancements, making the system ready for real world deployment. Thank you for watching this walkthrough, and I hope the demonstration has shown the capabilities of our system um, and how it leverages AWS services for cloud based deployment. Thank you.